Thank you for that introduction, Heidi, and thank you for that amazing welcome. This is my first DevOps Days that I've ever attended, whether speaking or just regularly attending, so it's awesome. Thank you. Let me tell you, it's really good to be here in person and see faces looking back at me from the crowd, so I really appreciate everybody who's come out today. Like Heidi said, my name is Keith Mattix, and I get the chance to talk to you about Service Mesh today, a technology that I'm very passionate about. I've got my Kubernetes shirt here, and Mesh is often on Kubernetes, so yeah, I love all the things there. Some info about me briefly before we get too deep into it. I'm currently based in Birmingham, Alabama. I'm originally from Memphis, Tennessee. Go Grizzlies. I'm a big Memphis Grizzlies fan, if you happen to follow the NBA. And for my day job, I am a senior engineer on the Open Service Mesh team at Microsoft. Open Service Mesh is a CNCF sandbox project, and kind of our goal is to create a service mesh that is based on open standards and is simple to use, manage, and configure. I'm a maintainer of the Service Mesh Interface CNCF project, and I'm also a founding lead of something new called the Gamma Initiative. Gamma stands for Gateway API for Mesh Management and Administration, and it's this really cool thing about trying to look at Gateway API and see if we can't apply that to service meshes. So if that sounds interesting, please come find me afterward. I'd love to tell you about the work that we've been up to. So before we start talking about service meshes, I want to start this talk off by talking about you. My goal for this talk, I title it To Mesh or Not to Mesh, and my goal for this talk is to help you answer that question. Not just you, but your organization, your management chain. Where does a mesh fall into your technology stack? And to do that, to help you answer that question, to give you the tools to take back after this conference, I think it's important that we start with talking about the problems that you're solving in your organizations. So I want to begin by talking about architecture. Chances are, if you're running Kubernetes in a microservice architecture, your VPC layout looks something like this. What we've got here is what I like to call a gateway layer. And the gateway layer kind of lives right kind of near the edge of your cloud provider. For the sake of this presentation, you're going to assume you've gotten through security groups, you've gotten through firewalls, you've gotten past all of your cloud-level security, and the traffic is trusted at this point, and you get to this gateway layer. This term gateway can be overloaded a lot. I realize that. And so the definition of gateway that I'm using when discussing this is a gateway is any set of network hops that adds context to your request. And I do mean this as far as a proper layer. I'm not restricting this to any particular technology. This could be a full-blown Kubernetes ingress controller, like Contour. Or it can be a traditional standalone proxy, like Nginx, or HA proxy, or Varnish, or something like that. And it doesn't even have to be one proxy or a fleet of similarly configured proxies. This can be multiple hops all doing different jobs. Maybe one proxy does auth-in or things like that. And so, again, this is a layer, a logical layer of network hops. And like I mentioned, the gateway layer is responsible for adding some sort of context to your request. And now, Keith, what do you mean by context? What I mean by context is that this gateway layer translates the request from something that is opaque and doesn't make sense to the rest of your system, and it adds information to that request to make it fit within your system. One of the primary jobs, one of the primary tasks that a gateway layer does in this respect is auth-in, auth-z. That stands for authentication and authorization, and this is the process of figuring out for any given request or connection, who does this request represent, and what are they allowed to do? And so you can start thinking about cracking open a JWT, and then associating that with the user, and investigating claims from that JWT. Or you can do cookie auth, or any number of different authentication authorization mechanisms that exist. Your gateway layer also typically handles telemetry. A good example of this is the X request ID header for HTTP requests. That X request ID is this unique identifier that persists throughout your entire application so you can identify that request. And the big thing that you often see done in your gateway layer is TLS termination. You may know this as SSL termination or HTTPS. They're all kind of the same name or different name for the same thing. And this is really useful to do in your gateway layer because restricting the certificate management of doing encryption between client and server and having that all live in one place makes managing things easier. So talked for about 5 minutes about this gateway layer. And once we get through this layer in our architecture, we get to the actual compute powering our organization services. And I want you to put yourself in the shoes of the average product engineer. And I think when you put yourself in that person's shoes, then you realize that most of what I just talked about is boilerplate. Right? This is not actively making my services do the business logic for my company. It has to be there, right? You can't necessarily route traffic without a proxy. You can't receive anything. But it's not what I'm living for. When that stuff breaks, I tend to call ops, right? That's not my problem. It's not what I get paid for. And I want to focus on business logic, right? I want to focus on the products and the features and the services that my organization provides so that we can make money. And with the rise of containerization, that's actually become more and more easy. Kelsey mentioned earlier in his keynote fireside chat that the idea of containerization completely changed and reimagined the way we deploy services. And the idea is that you can have the super lightweight deployment artifact that you deploy. And then you've got your file system, you've got some OS level packages, but outside of that, it's just your business logic. And you can just ship that to production, and then Kubernetes or your cloud provider's container management system can deploy it and put it somewhere, and you don't have to care about it. But you may look at this and you may say, Keith, this is not complete. This is not a complete picture. I can't just send that to production. If I only have business logic, how do I observe this? How do I see what's going on? Where's my logging? And I tell you, you're exactly right. For a production-ready application in 2022, we've got to have telemetry. We've got to have ways to observe the microservice that we're deploying to production. So, OK, we'll put telemetry in here. We will write some modules around doing this in our services, and we'll send it to our favorite log sync, and everything will be just peachy keen. But wait, we're in Kubernetes, or in VMs, or in your cloud provider's container orchestrator. That network traffic is not encrypted by default. And if somebody gets access to a node that's running this compute, somebody could start sniffing packets. And if you happen to be in a highly regulated industry and you're subject to things like FedRAMP or PCI or HIPAA compliance, that's your nightmare scenario, right? Somebody having access to potentially sensitive user info and sniffing those packets, you can't have that. And so what's becoming more and more common nowadays is to do some sort of service-to-service encryption. And that's not always easy. Many of you are doing that in your own organizations, and the burden of managing private key infrastructure internally, creating trust stores, distributing trust stores, and rotating things, having processes in place for when those things get compromised. It's difficult, and it's a lot of context to think about. It's a tall order, but ultimately, in a lot of cases, folks are finding that it is more than worth it, because at the end of the day, what's that adage about security? Security only works in layers. So you can imagine, and many of you don't have to, by the time that you invest in this private key infrastructure and you make each deployment artifact interface with that somehow, you're starting to kind of break the bounds of what you think a lightweight deployment artifact is. This is a lot of context to keep in mind. And when you onboard a new engineer to your team, they not only have to learn the business logic, they have to understand the telemetry system. They've got to handle this encryption in your application layer. And then we start adding in good traffic reliability concerns like retries or timeouts, things you need to do to make sure that you don't have unresponded applications. Now we see this idea of what we thought was a logically lightweight deployment artifact cracking under the pressure of all these concerns. Our mental model of what an application is can't hold up. Now we're shipping all these things that we didn't think we had to deal with. Wasn't the promise of containers that you didn't have to deal with shipping an entire compute instance to production? The promise of containers was that you ship your application, your business logic, and nothing else. Well, now you have to deal with all these concerns. And this sounds a lot like broken promises. And I'll confess, it's unavoidable that every architectural decision that you make has trade-offs. And microservices and containers are no different. Microservices are an extremely useful deployment pattern, and we've seen a lot of innovation in that space, the ability to move more agilely, if that's even a word. If it's not, then I just made it up, and now I'm going to mark it on it. But we see this ability to move with more velocity than we did before because our applications are decoupled and they're separate, and we can have different teams spun up to work on these things. But that has trade-offs as well. If you think back, my first framework was Ruby on Rails. And when I think back to writing my Rails applications, then I would have one code base, and when I had to do an operation, like, say, add a product to a cart or check out a cart, that was typically, I had to call it to my payment processor, but that was typically one operation that had different parts within a single code base. Well, now with microservices, you've got a network in between those requests. You may have to talk to 2 or 3 different services to get all the right dependencies in place to perform that operation. And here's the thing. Anytime you put a network in between your operation or within a single operation, you introduce risk to your system. Networks are inherently unreliable. And there are folks who do some amazing things with network engineering. But a lot of the work around network engineering is around redundancy. Because with anything that we do, failure will enter in. And that failure is not the only risk, right? When you put stuff on the wire, it inherently becomes more difficult to observe. We humans don't read bytes on the wire, so we've got to have orchestration to try to read that, and that can be complex. Like I mentioned earlier, you open yourself up to the possibility of those packets being sniffed in transit. And then there's the generic transient failures that occur when you put information on your network. And to many of you, none of this is new, right? These risks have existed for a long time, and they have to be managed. And typically, the way we manage those risks are with the things we've talked about: telemetry, encryption, and then retries and timeouts. There are a couple of other ways to go about managing that risk and keeping that logic in your application layer. One option is to pick a language like Java or the .NET framework, languages that are older than me. I'm 24, Java's like 27. But these are tried and true languages and ecosystems that have a lot of experience running things in production. And so we've got best practices that emerge out of that you can take advantage of. Or possibly you invest in an in-house utils library that you invest engineering time and effort to build. And you build wrappers that abstract around these concerns so that most product engineers never see that code. You get encryption automatically and things of that nature. And this is a 30-minute talk. I love talking about this, but I don't have time to go into every single trade-off here. But I've got some listed up here. But the bottom line is that while these approaches work very well for certain organizations, these too have trade-offs that can bite you. These concerns, when they're in the application layer, they never truly leave your product engineer's deployment artifact. They will stick around in your application layer for a long time. When you keep this logic in the code, there's inherent complexity that goes alongside that. And the annoying part is that complexity is right in the critical path of your product engineers building features that make your organization money. The surface and stack traces, and finding the active configuration is difficult to grok. You got overrides on overrides, and some of y'all know what I'm talking about here. What I'll suggest is that these concerns aren't actually application concerns, they're network concerns. And so one method of keeping these concerns in the network is through something called hairpinning. I mentioned the gateway layer before, and what we'll do is we'll take advantage of our gateway layer by sending all of our traffic through there. So if service A wants to talk to service B, instead of using the network fabric of my Kubernetes cluster or my cloud provider, wherever my network is, instead of using that, I'll send all my traffic through my gateway layer, through my proxy. And that gateway layer will give me my access logs. Everything's going in and out of there. So I've got my access logs there. I've got tracing for each request. And I've got some level of encryption that's there. And this is kind of nice because product engineers don't have to worry about this stuff. We'll just let the DevOps and SRE team handle this. And if there's one thing infra engineers have, it's free time, right? I got nothing to do. And so now I want to take a pause. I want to emphasize that each and every single one of these strategies that I've talked about here are viable. Right, these are possible options for you and your team and your organization, and there's nothing inherently wrong with them. But like anything else, there are limitations for you to keep in mind when going about this. And spoiler alert, service meshes are the exact same way. There are trade-offs associated with every single thing that you do, every decision that you make. And the first lesson that I want to try to give to you, yes, I assure you this is still a service mesh talk, but one of the first lessons I want to give when having the mesh conversation is make sure you pick the set of trade-offs that make the most sense for your organization. That's going to be how you have the better outcomes. So moving back to hairpinning, right, there are several reasons why this might not be the best thing for you. You lose context when you go through your load balancer because every request looks like an ingress request. You create a single point of failure on your gateway layer. If that load balancer, if that proxy ever goes down, then suddenly your service-to-service breaks as well. There are organizational challenges. You possibly pay zone egress cost. You add latency when you go in and out of the cluster. Lots of different reasons this might not work for you. So to address that, I want to take this example one step further. We've established that these concerns around telemetry, encryption, network resilience are network proxy concerns and not application concerns. And we tried going through the gateway layer through our existing proxy, and for one reason or another, that might not work for you. So what if we duplicate our proxy? Congratulations, we've just invented the modern service mesh. This is what, at the end of the day, service meshes do. It duplicates and distributes proxies in order to propagate context. And just to be clear, not every mesh uses a sidecar, and sidecars aren't mesh-specific, but the underlying concept remains the same. Distributing proxies, handling all incoming and outgoing traffic is going to give us the same benefits of our previous implementation without some of the downsides of hairpinning. I've got some examples of features up there, and we'll talk about more here in a second. But you're probably wondering, why did I spend like 2/3 of my talk talking about stuff you probably already know? What's the value here? Well, I hope that by starting with, by defining service meshes through first principles and kind of building up the reason and the rationale for it, we've learned the importance of framing. Service mesh is, at the end of the day, an evolution in proxy architecture. It is not a silver bullet to solve all your organization's problems. I want for you to take away from this talk that a service mesh is the next step or a natural progression for your organization's network stack. It's not some abrupt change that should come out of nowhere. And so instead of jumping straight into, hey, here's a mesh, let me tell you what it does, I wanted you to start thinking about the problem spaces that you're already dealing with in your organization. And I want you to start thinking about how meshes fit into that. Proper framing is critical for sound decision making. And when you have the mesh conversation in your organization, start with the problems. And think about how the mesh solves those problems. For best outcomes, take the time to frame the mesh conversation correctly. So with all that being said, let's finally define and answer what a service mesh is. At its core, a service mesh is a distributed networking plane for traffic management and policy. And policy here means often Z, timeouts, retries, pretty much anything you can do at a networking layer kind of counts as policy. And notice I just said distributing networking plane. Sidecars or Envoy or none of that's in this definition. This means that you may already be using a service mesh in your organization. Anything that distributes your network management can technically count as a service mesh. And what I want to point out here is that service meshes actually enable you to partake in industry standards and best practices more easily. If you look at the list of things that a production-ready application has to do in 2022, it's a pretty tall list. We've gone through timeouts, retries, encryption, and traffic management, and then, let's try to deal with service-to-service tracing and all this stuff. It's pretty difficult. And then we've got a cool talk coming about software supply chain security that, this list keeps growing and growing and growing. And the thing to point out here is that because of the rise of things like Kubernetes and orchestration platforms, more and more businesses have their deployment architecture look like a big tech companies, right? You're distributing your applications, doing microservices. But the problem with that is if you're a small, medium-sized business, you might not have the resources of a big tech company. You might not have the budget or the expertise or the time to invest to really figure out how to do these things at scale. But by using similar deployment patterns, you end up having similar deployment problems. And so for those organizations where a service mesh can be really helpful and add a lot of value, is you're able to get around 80% of the network deployment best practices just by opting into a service mesh. I also want to point out, again, I've said this a couple of times, I will keep saying it, service meshes aren't a particular proxy or data plane implementation. There are meshes that use Envoy, there are meshes that don't use Envoy. It's all depends on that distributed network plane definition. The only kind of common case here is that your proxy management is usually dynamic. But anyway, let's start spotlighting some of the features of mesh. I'm going to go through this kind of quick. This is not any particular mesh's features. There are some meshes that have some of these, or I don't know that any mesh has all of these. But for one, we're going to talk about traffic management and kind of spotlight on that. What most meshes often allow you to do is do some really cool traffic splitting. There are lots of things that fall into that category, like progressive delivery. So think Canary or blue-green deployments automatically, and there are some really cool third-party open source tools that help you do that. You can do selective traffic mirroring, so send a copy of request to another service for training or auditing and things like that. And the kind of, I guess the theme around traffic management for service mesh is that because you distribute your network proxy, you've got context that you can use to make more intelligent routing decisions. One example of that is advanced load balancing. Speaking in a Kubernetes context, each endpoint pod kind of knows where it is depending on the kind of the cloud provider or the provider of your cluster. So your pod knows, hey, I'm in this region in this availability zone. A service mesh can often take advantage of that to send traffic to, hey, maybe you can say, hey, keep all traffic in this AZ. Or, hey, this region's down, send traffic to this other region. Most meshes can do something like that. Observability, right? A lot of folks are using service meshes to unlock new observability features. Streamlined telemetry collection, again, everything's going through that proxy, so you can see all your traffic. You can unlock a dependency graph in real time. You can see, hey, who talks to my service, and who does my service talk to, again, in real time. And on that last question, you can do egress monitoring, which is really cool because you're able to see what requests leave your system to some external dependency. And this has some security implications, and I'm going to use that to segue right over to security. You have egress monitoring, which kind of acts as a firewall. You can do automatic MTLS. MTLS stands for mutual TLS, and it's just a situation, it's like regular TLS, but the client and the server both have certificates. And so you can do all these things, service isolation, authorization, et cetera, et cetera. So that's the feature side of things. That's really not what I want to talk about here. My goal at the beginning was I was going to tell you and equip you to answer the question to mesh or not to mesh for your org. So to do that, I want to talk about organizations. You say, Keith, why are we talking about organizations in a service mesh talk? Well, it's because of Conway's law. Conway's law states that organizations which design systems are constrained to produce designs which are copies of the communication structures of those organizations. That's a really fancy way of saying that our organizations impact the way we build software. And so I'll posit to you that we should strive to make sure our orgs are in harmony with our technology. And meshes are no exception. At the end of the day, meshes are software designed to be used by groups of people. And so I want to talk to you about how to optimize your organization for mesh. The big theme here is to favor transformational over transparent adoption. What do I mean by that? Oftentimes in DevOps and SRE, we strive to make our changes and our infrastructure transparent to where nobody can tell what is at work. And that's generally good API design. But I fear that if we make things too transparent, or we make changes that are too big while being too transparent, we throw our systems out of alignment with our organization. How are we going to bring our organization alongside us as we make technological migrations? A distributed network plane with service mesh means that you've got distributed responsibility. If we're truly going to practice service ownership, then it can't all be on DevOps or SRE or platform. Like whatever that group, that team is called in your organization, it can't be all on them to manage every aspect of your proxy. Are you giving your product engineers the tools and training to truly own their services? And while they may not be writing proxy configuration, they need to understand that these things are at play when designing things. A good test to know whether or not to see how you're doing with this is to look at your on-call escalation policies. If a service throws a 5xx error in the middle of the night, who's the first person that you page? Who's the first team that you page? If it's somebody on DevOps or SRE, then perhaps you're robbing your product engineers of a chance to truly learn how their services work and function. A mesh is a big change for any organization. To go from one kind of centralized gateway layer to a distributed proxy environment it can be incredibly difficult. And there's a lot of complexity that can enter in when making that switch. I would say try to use that failure as an opportunity to improve the learning and the understanding of your entire team, not just your infrastructure department. So we've talked about what a mesh is. We talked about what happens when you put these concerns that we've talked about in the application versus the network. So now I turn the questions over to you. To mesh or not to mesh? That is the question. And that's a question that I can't answer for you. But I hope, after spending some time together this morning, you have the tools, or at least more tools, to answer that question yourself. The biggest advice I can give when you're having these discussions and making these decisions is to listen. Listen to your users. Are they suffering in ways that a service mesh can help? Listen to your organization. This is the big one for me, I think. When your product engineers are asking for new features for their infrastructure, does a mesh address that? Is your team ready to adopt distributed responsibility? What do your on-call escalation policies look like? How do you do incident management? What's your culture like around owning your services? Start there, and that's going to help you answer that question. Remember that this is not a binary answer, right? This is not a yes, no, forever, end of discussion. Few things in tech are. If your answer is no, what are your signals to reevaluate whether or not a mesh is right for you? Right? What's your action plan? What things are you going to do to put into place to be able to get in a better spot objectively as an organization? And then once you've done that, how are you going to come back to the mesh conversation? And if your answer is yes, remember that this cannot be a completely transparent change. Things will break as you're going through this process. Prepare for that. And again, come up with an action plan for making sure that this is a transformational move for your organization, not just a transparent one. I realized that I probably left many of you with more questions than answers, and yes, that's on purpose. If you want me to bring up even more questions for you, and maybe some answers here and there, please come and chat with me. I'm on GitHub and Twitter as @KeithMattix. I'm also on CNCF and Kubernetes Slack pretty often. There's this really nifty thing we've got called Open Space that I'm excited to partake in, and if service mesh is something you'd like to talk about, then that's something that we can do. I'm happy to chat about service mesh or Gamma, Gateway API, and the stuff we're doing here with mesh, or basketball. I'm a big NBA fan. So without further ado, I'm done. Thank you.